In this video, we want to continue on with our fundamental theorem of algebra. We want to kind of combine many of the things we've already looked at. Understanding the graphs, finding roots and zeros on our calculator, but also using synthetic division and quadratic formula and trying to solve. What we want to do is, if we look at an equation like this, x cubed plus x squared minus 6x minus 6. And we want to find all the roots exactly, no decimals. Now, as we look at this, we could graph this on our calculator and find these roots. Now, as you look at it, you can see this root here and this root here appear to be decimals. I don't go through any whole number, any integer value. This one appears to be close to -1. So how do we find these? We could go to our calculator if we are unsure, and let's actually graph this. X cubed plus x squared, x cubed plus x squared minus 6x minus 6. If I do zoom 4 to get a decimal here, and I go to find my zeros. So if I go over here to the right, and it's kind of off the graph, and I want to find my, and one of the tips here is if you can't see your values on your calculator, you can't see your star. Notice the value here. This is -3.7, so it's negative, but it's going further negative. Now it's coming up. There, I finally can see it. If I go left, right, guess, I get -2.449489. Okay, that's some decimal. That's irrational. Now I know, remember from the first part of fundamental theorem, irrationals always come in pairs, which tells me one of these other values also has to be a decimal. Now, it looks pretty clear right here that 1 should be -1. So I'm going to go with -1 here, back here, and say, okay, I think it's -1. Now, what I'm going to do is synthetic division. Now, if I'm right, and it's -1, and I could check it on my calculator if I wanted to. I know it's right, so I'm not going to. If I do synthetic division correctly with the correct root, this should be 0. So I drop the 1, multiply, add, multiply, add, multiply, and I get 0. So that tells me -1 is a root. Now what I'm left with then is x squared minus 6. I now need to solve that to find the other two roots, because I know this is a cubic. By the fundamental theorem, we'll have 3 roots. I know this is a rational, and I know these two on the outside are irrational or decimal. So I need to find them exactly with radicals. So I need to solve x squared minus 6 is 0. One way is the quadratic formula. Now this, I can use our extracting the square root method because it's simplified, and I can get x is plus or minus square root of 6. So my answers are -1 and plus or minus square root of 6. Now on our calculator, we found this root to be 2.4494. So let's check. We got that to be our root. If I check and say, well, what is the square root of 6? I get the same answer. So now I'm pretty confident that we did that one right. So you can check your answers on the calculator, but we want our answers with no decimals and find exactly the roots. Let's look at another one. 14x squared minus x minus 4. Looking at my graph, it appears these don't go through any integer, but this is a quadratic. So I always want to get to a quadratic, because if I have a quadratic, I can always just pull out my quadratic formula. And by having the quadratic formula, this allows me to always be able to find the answer exactly with no decimals. This is plus, and let's figure out a calculator. 4 times 4 times 14 plus 1 is 225. The square root of that is 15. So I now have 1 plus or minus 15 over 28. So I get 16 over 28, or I get negative 14 over 28. And there are my two answers. Okay, and I could simplify those down. Okay. Hard to find those exactly on the calculator. So, what if I have x cubed plus x squared plus 4x plus 4? Looking at the graph, there's only one root. I know there's got to be 3 because it's a cubic. So I'm missing 2. So I know I have one real root, and I have 2 complex, imaginary roots that involve I. Only way to find those is quadratic formula. Once again, negative 1 is my root. Now, let me just mention here, I've had people in the past that have looked at this and said, well, I know how you do these. All you do on every problem is you do synthetic division by negative 1. No. It just so happened I picked 2 graphs where the root was at negative 1. So you do not always use negative 1. You have to look at the graph and see where does the graph have an x-intercept that is an integer. So we drop the 1, multiply, add, multiply, add, multiply, and I get 0. So that gives me negative 1 as a root, because I got 0. I also have x squared plus 4. If I set that equal to 0, I get x squared is negative 4. So x is plus or minus 2i. The only way to find imaginary roots is solving the quadratic by quadratic formula or factoring or something like that. There's no way to get them from the calculator. When you had irrational roots, we could check. Does square root of 6 equal 2.44? Yeah, we're right. There's no way for the calculator to do that. Now, let's say we have this 4th degree. So let's graph this. X to the 4th minus 2x cubed plus x squared minus 4. So it looks like I have 2 real roots. It's a 4th degree, so that means I'm going to have 2 complex roots. So I look at my graph, 1 and 2 is what it looks like. So I think I'm going to start off with negative 1. Once again, I'm going to need a negative 4. Drop the 1, negative 3. That is 3. That is 4. That's negative 4. I don't get 0. So what did I do wrong? I did this one intentionally wrong. There's no x. I need to make sure I do a 0. So make sure when you do these, you have to put in a 0 if you're missing a term. So 1, negative 3, 3, 4, negative 4, negative 4, 4. Now I get my 0. My other root was 2. So now I need to do 2 with my answer. 1, 2, negative 1, negative 2, 2, 4, 0. So now I'm left with x squared minus x plus 2. Now I know, can I factor that? Is it possible to factor? I know the answer is no. As I look at my graph, I only have 2 roots. That means I have 2 real roots. I have 2 imaginary, 2 complex. And the only way to find those is the quadratic formula. So we got to pull back out the quadratic formula. This gives me 1 plus or minus square root of negative 7 all over 2. So I'll have 1 plus or minus I square root of 7 over 2. So what are my answers? What are my roots? I have negative 1, 2, and 1 plus or minus I square root of 7 over 2. So all these problems are going to involve this. You're going to be given a function, cubic, quartic. You're going to have to look at the graph and determine what are the integers, what are the whole number, negative number solutions that I can then do synthetic division with. And I always want to get down to a quadratic. So then I could use quadratic formula to get all of my answers with no decimals exactly. Sometimes you may be able to solve them by extracting the square roots. Sometimes you'll need quadratic formula to solve. But they'll all work that same way. All right, we are now ready for the homework of FTA, Fundamental Theorem of Calculus 2, which combines our idea of zeros and conjugate roots and calculator and quadratics and polynomials and kind of brings that all together.